question number 5. So this is for forces. A 2.0 kilogram block on a frictionless surface. So if the question states that it is a frictionless surface, there is no friction. Friction is equal to 0. So it is acted upon by two external forces, F1 and F2. Sketch the free body diagram of the block and calculate the normal force acting on the block. Okay, so now the object, this square box, will be represented by a dot. Please remember to draw a dot, bukan the square itself. Miss tidak mau tengok kamu letak square, you have to draw a dot to represent the box. Okay, alright. So let us draw the arrow dulu. So this arrow F1 here, you can actually point it until it reaches somewhere there lah. So basically you can say that it will be pointing to this point here, to the edge of the box lah, macam tu lah. Okay, gitulah. Bila lah tu kamu faham juga. Okay, so basically if I'm drawing a dot to represent the object, the forces will be going out of the dot. Okay, so this is F2, this is F1. Okay, so I'm drawing the external forces dulu. Apa yang ada di situ sekarang. Okay, so this angle should be 30 degree juga lah. Okay, that is too big for 30 degree. I should draw gitu sikit lah. Okay, they don't really mind about your the size of your diagram. Okay, just make sure you draw everything lah. This is 45 degree, this is 30 degree, this is F1. Okay, now we are looking at the forces yang ada di the box itself. Okay, so does the box have mass? Yes, so dia ada weight lah. So weight is gonna be pointing down. Okay, so that is mg. Now, since it is on a surface, in contact with a surface, there will be a normal force. That is the reaction force from the weight in contact with the surface. Okay, so we label this as N. Okay, so that is your free body diagram. Now we have to calculate the normal force acting on the block, which is N. So now we have to consider what component? We can try to consider component Y only. Component Y only, because sekarang ni semua pun ada value. F1 tu ada, F2 pun ada. So F1 is equal to 6 Newton. 4 Newton. This is equal to 6 Newton. So kiranya kita boleh lah teruskan dengan Fy sebab information tu cukup. Okay, so Y component. What is happening at Y component? Total force at Y component is equal to 0 because the box is not moving. Okay, so it is staying there. Unless it's stated, unless the question cakap dia ada acceleration na ataupun dia moving. Okay, ataupun kalau dia cakap uniform velocity, acceleration pun masih equal to 0. Okay, so what is the forces what are the forces in Y? So firstly we have N. N is positive because it is pointing up. Mg is negative. Now we have to consider F1 and F2 punya nilai X. So F1x is both of these forces are pointing to the right. So F1x will be positive. What positive it is? We are looking at Y component lah. Sorry everybody. So we are looking at Y component. So since F1 is pointing down, it will be negative F1 sine 30 degree. Okay, and then F2 Y component is pointing up, so it is positive F2 sine 45 degree. Okay, so F1Y is minus F1 sine 30 degree. plus F2 sine 45 degree equal to 0. So n is just mg plus F1 sine 30 degree minus F2 sine, why is it 45 degree? Oh, memang 45 pula. 45 degree. So, dapatlah nilai the normal force, which is equal to 17.38 Newton. Alright? Okay, so that is very straightforward, and that is the solution on question number 5.